40 light-years from here. Across the cold, silent expanse of space, stars are dying, and they aren't going quietly. They're feasting, devouring everything in their path, and their victims? Entire worlds. Some as massive as Jupiter, others small and rocky, just like our own Earth. It sounds like something straight out of science fiction, but it's not. This is the chilling reality for many planets orbiting aging stars. And it forces us to ask a terrifying question. Could our own sun one day turn on us? Could Earth be next? To understand how a star can eat a planet, we first have to understand how stars live and how they die. Think of them as cosmic power plants. They're born in vast clouds of gas and dust where gravity pulls matter into a dense, superheated core. Once that core gets hot enough, nuclear fusion ignites and a star is born. For billions of years, stars like our sun shine steadily, converting hydrogen into helium, warming their planets, and giving life a chance to flourish. But they aren't immortal. They're like cosmic candles, slowly, inevitably burning down. Eventually, a star exhausts the hydrogen fuel in its core. What happens next depends on its size. For a star like our sun, its final act begins with a dramatic transformation. It will swell into a red giant, a bloated, fiery, unstable version of its former self. Its surface will expand hundreds of times, engulfing the inner planets in a fiery embrace. As it swells, the planets have no choice but to face the intense heat, the powerful tides, and the relentless pull of their dying star. For decades, scientists debated whether stars really consume their planets. Was it just a cool theory, or did it actually happen? The proof came from an unexpected place: white dwarfs, the tiny, dense remnants of dead stars. When a sun-like star dies, it sheds its outer layers, leaving behind a super-compressed, Earth-sized core. For a long time, white dwarfs seemed like quiet, celestial graveyards. But when astronomers looked closer, they found something extraordinary. Using powerful spectrographs, they detected heavy metals like iron, calcium, and magnesium in the atmospheres of these dead stars. Now, why is that so remarkable? Because a white dwarf's gravity is absolutely immense. Any heavy elements should sink to the core almost instantly. The only way they could still be floating in the atmosphere is if the star had recently consumed something. The evidence was clear: these stars had been feasting on the wreckage of their own planetary systems. Even more astonishing, some showed debris from planets that were once as large as Earth worlds that were shattered, torn apart, and sent spiraling into oblivion. But how exactly does a star devour a planet? It's not a simple act of eating, it's a violent, complex process. As a star expands into a red giant, its outer layers can reach the orbits of Mercury, Venus, and possibly even Earth. Any planet caught in this expansion faces extreme heat and friction. Its atmosphere is stripped away. Its surface melts into a global ocean of lava. Its very core might begin to boil. If a planet is close enough, it gets dragged into the star's searing atmosphere. Inside this fiery envelope, the planet spirals inward, losing energy and heating the star's outer layers. For some planets, the end is swift and total. For others, it's a slow, agonizing death as they are torn apart over thousands of years. Either way, they leave behind a telltale signature of heavy elements, a cosmic crime scene that scientists can detect from light years away. All of this brings us back to that one terrifying question: what about us? Our sun is about 4.6 billion years old, comfortably middle-aged. But in about 5 billion years, it will run out of hydrogen and begin to swell. Mercury? Gone. Venus? Engulfed, and Earth. Our planet's fate hangs in the balance. Some models suggest Earth's orbit might expand just enough to escape the sun's fiery grasp. But other simulations are less optimistic. They predict that tidal forces and friction will drag our planet inward, where it will be incinerated, its molten rock cascading into the sun's blazing inferno. Even if Earth physically survives, it will be a scorched, unrecognizable husk. The oceans will boil away, the atmosphere will be stripped into space, and life as we know it will be utterly impossible. We don't have to just imagine this. Astronomers are watching it happen right now, across the galaxy. Take the white dwarf WD 1145 plus 017, located 570 light-years away. Scientists have observed a planet literally disintegrating as it orbits this dead star, creating a massive dust cloud that periodically blocks its light. We are witnessing planetary death in real time, a slow, inevitable spiral into oblivion. Then there's the red giant BD plus 48,740, which shows evidence of having recently engulfed an inner planet, destabilizing the orbits of the remaining worlds in a chaotic dance of destruction. These examples reveal a universal truth. Planetary engulfment isn't a rare fluke. It's a common, inevitable stage in the life cycle of many stars and their planets. It's easy to feel small and helpless when thinking about these cosmic timescales, but there's also a lesson in survival here. By studying these distant systems, we can better predict our sun's future, and we have time. 5 billion years is an almost unimaginable expanse of time. It's enough time for humanity to explore, to expand beyond Earth, to reach for the stars before our star reaches for us. Perhaps our descendants won't have to watch their home planet be consumed. Perhaps they'll carry Earth's legacy to new worlds, long before our sun begins its final act. Imagine it. Billions of years from now, our sun, swollen and red, dominates the sky. The oceans have evaporated. The continents have cracked under the immense heat. The sky glows orange and crimson. The planets closer to the sun have been shredded into rings of dust and metal, slowly spiraling into its core. This is the cosmos at its most dramatic. A powerful reminder that the universe is not static. It is alive, it is violent, and it does not wait. Every star has a story, and for many, that story ends in consumption. So is Earth next? Maybe not. What we do know is that the universe is a place of both creation and destruction. Stars give life, warmth, and light. And stars also take it all away. In the grand tapestry of cosmic time, our existence is just a fleeting spark. But within that spark lies our curiosity, our resilience, and our imagination, qualities that might just allow us to transcend our planetary cradle and survive our star-esque final moments. So, tonight, when you look up at the sky, remember, the stars are more than just beautiful points of light. They are giants slowly aging, powerful and hungry. And one day, even the brightest of them can turn on the very worlds they once nurtured. We often think of stars as eternal beacons, but the truth is far more dramatic. Stars are born, they live, and they die. And when they die, they don't always go quietly. Stars like our sun are cosmic powerhouses, fusing hydrogen into helium in their cores for billions of years. This steady burn provides the light and warmth that makes life possible. But this process can't last forever. When a star exhausts the hydrogen fuel in its core, its life takes a dramatic and destructive turn. The core collapses under its own gravity, heating up intensely. This triggers a new phase of fusion in a shell around the core, causing the star's outer layers to expand to monstrous proportions. The star becomes a red giant. For a star like our sun, this expansion is colossal. It will swell to a size that could easily engulf the orbits of Mercury and Venus. Any planet caught in this fiery expansion faces a perilous fate. It's not a quick swallow, but a slow, agonizing death spiral. Later in its life, the star enters what's known as the asymptotic giant branch or AGB phase. Here, it sheds enormous amounts of its mass through powerful stellar winds. This mass loss can alter the orbits of the remaining planets, flinging them into new paths or sending them spiraling inwards. Finally, after puffing away its outer layers, all that remains is a tiny, super-dense core called a white dwarf. But even in death, the star's influence remains. This stellar remnant can still pull in nearby planetary debris, leaving behind tantalizing clues of the planetary system it once hosted. This isn't just a theory. Astronomers have found compelling, real-world evidence of stars devouring their planets. One of the biggest clues comes from those white dwarfs we just mentioned. A white dwarf's intense gravity should quickly pull all heavy elements, like metals, down below its surface, leaving a pristine atmosphere of only hydrogen or helium. But when we look at them, we find something strange. Many white dwarfs are polluted. Their atmospheres are full of elements like iron, calcium, and magnesium. Where did these metals come from? The most likely answer is that they are the ground-up remnants of asteroids, moons, and even entire rocky planets that were torn apart and accreted onto the star's surface. It's like finding crumbs on a dinner plate, proof that a meal took place. In some cases, we've even caught a star in the act. So how exactly does a star eat a planet? It's not as simple as just swallowing it whole. The process is a combination of brutal cosmic forces. As the star expands into a red giant, its immense gravitational pull creates powerful tidal forces on any nearby planet. These forces stretch and deform the planet like pulling on a piece of clay. If the planet gets too close, these tides can become strong enough to rip it apart entirely, shredding it into a stream of debris. But what if the planet is a bit more resilient? As it enters the star's tenuous outer layers, it's like flying a spaceship through a thick atmosphere. The planet experiences friction or drag from the stellar gas. This friction slows the planet down, causing it to lose orbital energy and spiral inward, deeper and deeper into the star's fiery envelope. As the planet spirals to its doom, it transfers its orbital energy to the star, which can actually spin the star up, changing its rotation. For worlds that get perilously close, even before they are engulfed, the intense heat is enough to boil away their atmospheres and melt their surfaces, a process called ablation. Over thousands or millions of years, the planet is either stripped down to its bare core or vaporized completely. The consequences of this cosmic drama are profound for the entire planetary system. Many planets are simply erased from existence. They are completely destroyed, their material mixing with the stars or forming a glowing disk of debris around the white dwarf remnant. These debris disks, made of the ground-up guts of planets, are detectable by infrared telescopes like the James Webb Space Telescope. They are the tombstones of a lost solar system. But not every planet is doomed. Outer planets, especially gas giants like Jupiter or Saturn, are often far enough away to survive the star's red giant phase. However, their lives are forever changed. As the star loses mass through its stellar winds, its gravitational grip weakens. This can cause the orbits of the surviving outer planets to expand, pushing them farther out. In some cases, the shifting gravitational landscape can send these survivors into new, more eccentric orbits, creating a chaotic dance of worlds in the aftermath of the inner system's destruction. This brings us to a question that hits a little closer to home. What about us? What is the future of Earth and our solar system? In about 5 billion years, our own sun will begin its transformation into a red giant. Mercury and Venus, being the closest, are almost certainly doomed. They will be vaporized by the sun's expanding outer layers. Earth's fate, however, hangs in the balance. It's a cosmic race against time. As the sun expands, tidal forces will try to drag Earth inward. But at the same time, as the sun loses mass, its weakening gravity will try to push Earth's orbit outward. Which force will win? Scientists are still debating it. But even if Earth narrowly avoids being swallowed, it will not be a haven. Long before the sun reaches its full red giant size, the increasing heat will trigger a runaway greenhouse effect. Our oceans will boil away, the atmosphere will be stripped into space, and the surface will become a molten, lifeless rock. The planet itself might survive as a charred cinder, but all life will have been extinguished millions of years before. The long-term outlook is clear. For humanity or any life that follows us to survive, we must eventually become a multiplanetary and ultimately an interstellar species. Our home planet has an expiration date. The study of planetary engulfment is more than just a morbid curiosity. It's a fundamental part of understanding how planetary systems evolve. By studying polluted white dwarfs, we can essentially perform an autopsy on a distant solar system. The composition of the debris tells us what those destroyed exoplanets were made of, giving us unprecedented insight into their geology and internal structure. It's like being a cosmic archaeologist reconstructing lost worlds from their ashes. Recent discoveries have shown just how common this process is. Thanks to powerful observatories like the James Webb Space Telescope, we're getting an incredibly detailed look at the debris disks around white dwarfs. We can analyze their chemical composition and see the building blocks of planets. Studies now suggest that a quarter to even half of all white dwarfs show signs of planetary pollution. This means that for billions of star systems across the Milky Way, a violent, fiery end is not the exception, but the rule. This cosmic perspective reminds us that our own solar system is not static. It's a dynamic, evolving place, and on astronomical timescales, it is fragile. Let's try to visualize this. Imagine you're on a rocky world, orbiting just a little closer to your star than Earth. For billions of years, it's been a stable home. But now, your star is swelling. The sky is no longer a distant point of light, but a colossal, burning wall that fills your vision. The oceans begin to boil, the continents crack and glow with heat. Your world is pulled, stretched, and begins to disintegrate as it spirals into the star's atmosphere. From the perspective of a distant gas giant, the inner system becomes a chaotic inferno. The familiar planets vanish one by one, their light swallowed by the expanding star. The entire architecture of the solar system is rewritten in a storm of fire and gravity. It's a vision of both incredible destruction and awesome cosmic power. So why does all of this matter? Understanding stellar engulfment is crucial for the search for life beyond Earth. It helps us define the true lifespan of a habitable zone around a star. It's not enough for a planet to be in the right place. It has to be there at the right time, before its star enters old age. It sharpens our cosmic perspective, reminding us that nothing in the universe is permanent. The stars and planets we see today are just a snapshot in a cosmic story that has been unfolding for billions of years and will continue long after we are gone. It's a humbling and perhaps motivating realization about our place in the cosmos. Thank you so much for joining me on this journey to the fiery end of worlds. It's a powerful reminder of the dynamic and sometimes violent nature of our universe. If you found this as fascinating as I do, please hit that like button, subscribe for more cosmic explorations, and ring that bell so you don't miss our next adventure. Let me know in the comments what you think Earth's ultimate fate will be. Until next time, keep looking up.